Once you've created your station, now you can begin to create your points, graphics, control logic, histories, and other objects in the config container. We'll begin by creating a folder inside of our config object. I'm going to right-click in the nav tree on the config object, and it brings up a pop-up menu of actions that I can perform on that config object. I'm going to go to the new menu, and I'm going to create a new folder here. And I will call this folder Cafe. I'll click OK to create the object. Now I don't see it immediately visible on the screen. What I have to do is go to the nav tree and expand the config object. And we see that whenever we create a new object, it's at the bottom of the tree within that object, that cafe object. That cafe object is a child of the config object. It goes to the bottom of the list of the child objects of config because it's the newest object. If I double click on that cafe folder, I see the default view of the cafe folder, which currently is the wiresheet view. The wiresheet view allows us to see the objects inside a container and to view any logic or connections they may have to other objects in your station. Next, I'm going to add an object that represents a fan control. So we're going to create an object that turns an exhaust fan on and off. There's several different ways I could do this. I'm going to show you how to use something called the kit control palette to create this exhaust fan object. To access pallets within the Workbench, you need to open the Pallet Sidebar view. The easiest way to achieve this is to go up to my toolbar and find the Sidebars menu. Within that Sidebars menu is something called the Pallet Sidebar. Opening up the Pallet Sidebar allows me to access the palettes that are contained within all of the modules that make up the Workbench software. To open up a palette, I can simply drag my mouse to the folder icon and click on the Open Palette folder icon. This pops up the Open Palette pop-up window. Here I can scroll through the list of system palettes and find the palette for the module I want to work with, or I can use the filter to narrow down my choices. In this case, I'm looking for a library of control components that are contained in the kit control palette. And so if I filter for the word kit, I can select the kit control palette and click OK. Notice the palette is organized into folders that have groupings of objects based on their use. I'm looking for an object that will allow me to control a fan that turns on and off. If I expand the control palette, inside the control palette is a folder labeled Points. If I click the triangle to expand the points, there I will see the 8 basic Niagara point types. Because this fan will turn on and off, I'm going to select a Boolean object. And because I'm going to command the fan on and off through the object, I'm going to select a Boolean writable, which is a commandable point. The other option, a Boolean point, is for statuses. It represents the value of a point that turns on and off, but I cannot command it to turn on and off through a Boolean point. And so I can drag the Boolean writable object out of the palette and drop it onto the wiresheet of my cafe folder. And when I do that, I get the opportunity to rename the object. Notice I did not use a space in naming the object. It is good practice to avoid using spaces in object names. You can, however, use an underscore if you wish to have some separation between multiple word names. I'll click OK, and a block that represents the exhaust fan control is added to my cafe wire sheet. I can use my mouse to click on it and drag it around the wire sheet and position it where I want it to be on the page. While I have the block selected, I could use the squares on either side of the block to expand that object and make it easier to read. By default, a Boolean writable shows me the object name, exhaust fan, the object type, Boolean writable, and then three properties or slots of that object: the out, the in10, and the in16. The out provides three pieces of information about that object: its present value, its status, and if it's a writable point, its command level, or which input is currently controlling the writable point. We also have two inputs that we can write to displayed on the block: input 10 and input 16. These are two parts of the priority array of a writable point. If I double-click on the exhaust fan, I can see that there are 16 levels of writable priorities for a writable point. The lower the number, the higher the priority. So that input level 1 is the highest level of control for a writable point. Input level 1 can only be written to using an emergency override command. If I right-click on the name of the point, the exhaust fan, and go to Actions, emergency active or inactive would write to priority 1. A regular override, active or inactive, would write to priority level 8. To release an override, all one needs to do is send an auto command, an emergency auto command for an override at priority 1, and an auto command for an override at priority 8. Using the set action, writes to the value of the fallback. In this case, I have set the fallback for this fan to be false, which means that the fan will be off if it's not being controlled by any command priority 1 through 16. The last thing I will show you here is how we can change the facets of this point to change how the present value is displayed. Currently, the value will be displayed as true or false. If I want to change that, I can go to the Facets property and click the little double arrows pointing to the right, which gives me the opportunity to configure the facets, in which case I can change the value displayed for true to on and false to off. When I click OK and save my changes, now when I refresh the screen, you'll notice the out property says that the value of this fan is off, its status is OK, and it's being controlled at the default priority, which is our fallback.